Greetings, students. So today we're going to talk about how to solve quadratic equations by factoring. And to start off, we have to learn something called the zero product property, which we also annotate as ZPP, zero product property. So the idea here is that if you have an equation that has two factors equal to zero, so if you have a times b is equal to zero, then the only way for that to happen is if either a is equal to zero or b is equal to zero or both. That's the only way that the product is equal to zero. So therefore, if we have uh, if we have a function y equals x minus 2 times x minus 6, then, and we want to find its zeros, then we can set the whole equation equal to 0. So it would be x minus 2 times x minus 6 equal to 0. And then from there, we can set each factor equal to 0. So a factor, of course, are the parts that are being multiplied. So therefore, we'll have x minus 2 equals 0, and we'll have x minus 6 equals 0. So basically, this tells us that if the product is equal to 0, then either x minus 2 has to be 0 or x minus 6 has to be 0. And then we solve both equations. Well, these are one-step equations, so we add 2 to both sides for the first one, and therefore we'll end up with x equals to positive 2. Or we add 6 to the if we're solving the other equation, and then we'll end up with x equals 6. Then we can write our answer in what's called set notation, and to do that we use curly brackets. So in other words, we use brackets like this, the curly brackets, and we'll just say that our answer is 2, 6. That's called set notation. It basically means that we have a set of answers, and that set of answers is 2 and 6. Okay, so right now let's do a few more examples using the zero product property. Now, what's very important to realize is that this works only if the result is 0. It will not work with any other number. So we have an example 1, x plus 4 times x minus 3 equals 0. So we set each one of these factors equal to 0. So we'll have x plus 4 equals 0, and then we'll have x minus 3 equal to 0. And then we just solve both of these equations separately. In the first case, we have to subtract 4 to the other side, and therefore we'll end up with x equals negative 4. Then in the other case, we'll add 3 to the other side in order to solve this equation, and we'll end up with x equals positive 3. And even already put those boxed those answers, we should write them in set notation. So in the curly brackets, we'll have answers such as negative 4, 3. So that would be our actually final answer. Okay, so next example, to x plus 5 times x plus 3 equals 0. Once again, because it is equal to 0, we can set each one of these factors equal to 0. So we'll end up with 2x plus 5 equals 0 and x plus 3 equals 0. And now we'll have to solve both. Now, the one on the left is a two-step equation, so we will take a few steps to solve this one. So first we subtract 5. And then we'll end up with 2x equals negative 5. And then we divide by 2. And we'll end up with x equals negative 5 over 2. So we can write it as a fraction, or we can write it as a decimal, negative 2.5. The second equation is much faster. It's a one-step equation. So we just subtract 3, and we end up with x equals negative 3. Once again, I would like to write both answers in the set notation. So in the curly brackets, we'll have negative 2.5, comma, negative 3, and close the curly brackets. So these are two of our answers here. Okay, last example, we have x times x minus 6. So this one is looks a little tricky because we don't have two sets of parentheses, but what we have to realize is that x is its own factor. So here, this is x times x minus 6. Therefore, we set each factor equal to 0, and it turns out that we'll have x equals 0. So x is its own factor, and then x minus 6 equal to 0. If it's easier for you, you can think of this x as being in the parentheses, so we can put parentheses around this x, and that way you see that you can set both parentheses equal to 0. So this one where it said x equals 0, that's already solved for us. There is nothing for us to do. X minus 6 equals 0, we do need to solve this equation, so we have to add 6 to both sides. We'll get x equals to 6, positive 6, and then we'll write down our answer in set notation, like this. Okay, now this is when things are already factored for you. Notice, so remember, to be factored means that your expression is written as a product. But a lot of times things are not factored, and that's what we've done previously. We've talked about how to factor quadratic equations or quadratic expressions. So for example 4, we have x squared plus 4x plus 3 equals 0. So we have to recognize that this is a quadratic trinomial. Therefore, we will have to make a t-chart. Most of you probably will make a t-chart where you multiply a times c, and then we have b. So remember that your a is 1, so we multiply a times c, which would be 1 times 3, which is equal to 3. So we need to find numbers that add to 3 and multiply to 3 and add to the middle number, which is your b, which is 4. Okay, so these numbers would be 3 and 1. So you have 3 plus 1. Now, once you find these numbers, we can factor this expression. So we will break up the middle term. Some of you skip that step, and that's okay. But in my classes, I usually show that step. So we break up 4x using these numbers that we just found, 3 and 1. So therefore, we'll have x squared plus 3x plus 1x plus 3 equals 0. So that 3 and 1 is right there. And then we factor by either grouping or by using boxes, and I'm pretty sure most of you use boxes, so that's what I'm going to do here. So we'll write out all of our terms inside of the boxes. So we'll have x squared, then 3x, then 1x, then 3, and now start factoring out common factors. So in the first group, the common factor is x, so we divide everything by x, and we will end up with x plus 3. In the second group, the common factor is 1, and if we divide everything by 1, we're just double checking ourselves. So 1x divided by 1 is x, and 3 divided by 1 is 3. So everything is correct. So these are our factors. So we end up with x plus 3 times x plus 1. However, keep in mind that's not the final answer because now we're solving an equation. So this is the factored form, but this is the expression that should be equal to 0. And now we have to use our zero product property, where we will set each one of the parentheses equal to 0. So x plus 3 equals 0, x plus 1 equals 0. Subtract 3 on both sides, so we get x equals negative 3. Subtract 1 on both sides, so x equals to negative 1. And therefore, our answer or set of answers is negative 1, comma, negative 3. By the way, it doesn't matter in which order you write your answers in curly brackets. Any order is correct. Okay. And therefore, this is our final answer here. Okay, let's continue. Example 5. So once again, we have a quadratic trinomial that's equal to 0. So first of all, we need to factor this quadratic trinomial. We need to find, we're going to multiply our a and c. Our a is 1. Our c is negative 27. So 1 times negative 27 is negative 27. Middle number is 6. So we need to find numbers that multiply to negative 27 but add to 6. Since 27 is negative, that means that the number should be positive and negative. So the set of these numbers that we can use is probably negative 3 times 9. And then if we try it, negative 3 plus 9 does equal to 6. So from here, we're using negative 3 and 9 to break up 6x. Therefore, we'll end up with x squared plus, it doesn't matter in which order you write your 3 and 9. Sorry about that. So minus 3x plus 6x minus 27. Okay, so once again, we're using -3 and 6 that we found in a t-chart. Oops, my bad again. It's not 6, it's 9. Yeah, so we're using 3 and 9 that we found in the t-chart. Okay, now from here, we're making a box again. So we can factor our expression. So we have x squared, negative 3x, 9x, and negative 27. And now factor out the common factors. So in the first row, the common factor is x, and we divide everything by x to get x and then negative 3. In the second row, the greatest common factor is 9. So we divide everything by 9 to double check ourselves, and we do get x and negative 3 again. So our factored form will be x minus 3 times x plus 9. And remember, this is still equal to 0. Now from here, we set each factor equal to 0. X minus 3 equals 0, x plus 9 equals 0, and then we add 3. So we get x equals 3. We subtract 9, so we get x equals negative 9, or in the set notation, once again, it would be negative 9 comma 3. Once again, doesn't matter in which order you write your answer. All right, let's continue on. And now for question 6 and 7, things are a little bit different. For question 6, notice that your expression is equal to 21. So very important to remember that if you have a quadratic equation, and that's what we have right now because we have a quadratic expression since it has x squared as the highest power, the only way to solve it, and that we know right now at least, is if it's equal to 0. So it's equal to 21, so we cannot factor anything right now. Or we could, but we shouldn't. Instead, we have to set it equal to 0 first. So to do that, we have to move 21 to the left side. And to do that, we subtract 21. Now, once we do this, notice there are no like terms on the left side. So we'll just end up with x squared plus 4x minus 21 equals to 0. So now at this point, since our quadratic expression is equal to 0, now we can continue solving it just like we've done previous examples. So we have to multiply 1 and negative 21. And that will give us, of course, negative 21. And the middle number is 4. So we need to find numbers that multiply to negative 1 and add to 4. In this case, it would be negative 3 times 7. And negative 3 plus 7 does give us 4. And then we factor. So break up the middle number. So x squared minus 3x plus 7x minus 21. We don't need to set it equal to 0 yet. Okay, so we're using the 3 and 7, then using our box. We'll end up with x squared, negative 3x, 7x, and negative 21. And the greatest common factor in the first row is just x. Then we'll end up with x and minus 3 in the top. The greatest common factor in the second row is 7. And then we divide everything by 7. We get the same expression as on the top. And then we'll end up with x plus 7 times x minus 3. And now we set it equal to 0. And therefore, we set each one of the factors equal to 0. And from here, we get x equals negative 7 and x equals 3. And therefore, we get 3 comma negative 7 as our final answer. Okay, question 7. Once again, notice that it is not equal to 0, so we have to move the 7x to the left side, and we subtract it. But now we do have a like term. Notice that there is an x term in the middle, so we'll subtract the 7x from the term in the middle. And once we do this, we end up with x squared, and then negative 5. So we will be subtracting negative 5x and negative 7x, and that will produce negative 12x minus 64 equals 0. But at this point, we do everything exactly the same. So we multiply a times c, so 1 times negative 64 is negative 64. And we need to find numbers that multiply to negative 12. And these numbers could be, and I have to think about this ones. So it will be negative 16 and positive 4. So this one's a little bit harder numbers, but then when we check it, negative 16 plus 4 does give us negative 12. Okay, so we continue on. So we're using negative 16 and 4 to break up negative 12x. So x squared minus 16x plus 4x minus 64. Okay, and then making our box and basically continuing on the same way as we've done before. So in our box now, we have x squared, negative 16x, 4x, negative 64. So you get x out, divide everything by x. So we'll have x minus 16. In the next common, in the second row, the common factor is 4. Divide everything by 4, and that will work out. And therefore, we get x minus 16 times x plus 4 equals 0. And from here, we set each factor equal to 0. So x minus 16 equals 0, x plus 4 equals 0. And therefore, we get x equals to positive 16, x equals to negative 4. And in the curly brackets, we can write it as negative 4 comma 16 as the set notation. All right, so these are your examples on how to solve quadratic equations by factoring. But now let's see how we can use it to help us graph quadratic functions. So we have the equation y equals 6x, y equals x squared plus 4x minus 5. So first of all, we need to find the axis of symmetry. Okay, so the axis of symmetry, remember, to find it, you use negative b divided by 2a. And our a is 1, our b is 4, and our c is negative 5. Okay, so based on this, we'll end up with negative 4 divided by 2 times 1, which is negative 4 over 2, or negative 2. So the axis of symmetry is x equals negative 2. Keep in mind, it has to be written as an equation. Now, to find the vertex, it's the same thing as the axis of symmetry. You use that x value, but then you have to substitute it in to find your y value. So we'll get y equals, and now we're substituting this negative 2 in for the axis. So therefore, we'll end up with negative 2 squared plus 4 times negative 2 minus 5. And we'll have to calculate that really quickly. So it will give us 4 minus 8 minus 5, and we get negative 9. So therefore here our vertex would be negative 2 comma negative 9. And since our a is a positive number, then our shape will be concave up. So concave up means it's gonna go this way, which means our vertex is at the bottom, which means it will be the minimum. Now the y-intercept, remember for the y-intercept, the x-coordinate is always 0, so we just need to find the y-coordinate. And since we know what the x-coordinate is, we're going to substitute it for the x values. Therefore, we'll end up with y equals 0 squared plus 4 times 0 minus 5, and that just gives us negative 5. And finally, x-intercepts. Well, x-intercepts, remember, happen when our equation is equal to 0. So to find the x-intercepts, we will set the whole equation equal to 0. In fact, yeah, we can do that. So we'll end up with x squared plus 4x minus 5 equals 0. Now, from here, notice that it's an equation that's equal to 0, so we're going to solve it the same way as we've done previous examples. We multiply a times c, which is -5, b is 4. So the numbers that multiply to -5 but add to 4 are -1 and 5. And now from here, we break up the middle term. So we end up with x squared plus 5x minus 1x minus 5 equals 0. So now continue on. So x squared, 5x, -1x, -5. The greatest common factor in the first row is x. So we divide everything by x and we end up with x and 5. In the second row, it has to be -1 since our first number is negative. And then once we divide by -1, we do get x and 5 as well. So therefore, we end up with x plus 5, x minus 1 equals 0, and then set each factor equal to 0. So we end up with x equals -5, and x minus 1 equals 0, so x equals 1. So our x-intercepts are -5, 0, because your y value, notice, remember this was your y, so y value is 0, and then 1, 0. Okay, so now let's see what we have for our table and to graph the function. So first of all, we're gonna always start with plotting the vertex. So our vertex is -2, -9. So -2, -9 is right here, big red dot. That's our vertex. Then we have y-intercept of 0, -5. Okay. And then we also have x-intercept of -5, 0, and 1, 0. So through the vertex, we always have the line of symmetry or axis of symmetry. It's our parabola will be symmetric over this. And notice to fill in the rest of our parabola, we can count, we have the points are symmetric. So these 2 points are already symmetric, but then this point is not. So we have 1, 2, 1, 2. So now we have a symmetric point here, and we can draw our graph. And if we wanted to fill out the table, in the middle, we usually put our vertex, -2, -9. And then we have points to the left of the vertex. So -4, -5. And then we also have 0, -5. And we also have point 1, 0 and point -5, 0. Okay, let's do a couple more examples. Okay, so this next one, we have y equals x squared minus 9. So once again, we need to know our a, b, and c. So a is 1. Now, notice there is no b term. So that means that b term is 0. So in fact, actually, I will rewrite this as y equals x squared, but then plus 0x, and then minus 9. Okay, so the middle term that was missing, it's the same thing as being 0. So therefore, we have a equals 1, b equals 0, and c equals -9. Now, axis of symmetry is still -b over 2a, but in this case, it's going to be negative of 0 divided by 2 times 1. And 0 divided by anything is always 0. So axis of symmetry is x equals 0. To find the vertex, we still do it the same way as before. We substitute this value in for x. Therefore, we'll have 0 squared minus 9, which is -9. Therefore, the vertex is going to be 0, comma, -9. Once again, since our leading coefficient, our a is positive, it's +1, that means it's concave up, means the graph looks this way. And that means that our vertex would be at the bottom, making it a minimum. Y-intercept. For y-intercept, remember, you always substitute 0 for x. So therefore, you have 0 squared minus 9, which is negative 9. And notice that your vertex and your y-intercept are actually the same point in this case. Now, to find the x-intercepts, we once again set the equation equal to 0. So x squared minus 9 equals 0. Now, from here, we need to factor this, but we might notice that 9 is a perfect square, and we have the minus between them. So this is a difference of squares. So that means that we can take a square root of both of these terms and factor this with a plus and a minus. So square root of x squared is just x, square root of 9 is 3, and then we have x minus 3. So here the factoring was much faster because it's a difference of squares, and now we set each factor equal to 0. So x plus 3 equals 0, x minus 3 equals 0. So x equals to negative 3 because we subtract 3 to the other side. On the other one, we add 3 to the other side, so x equals to positive 3. Remember, the x-intercepts always have y equal to 0, so we have negative 3 comma 0 and 3 comma 0. It's positive. Okay, so let's see what points we have. So we have the vertex, which is 0 and then negative 9. And then we have, so that's going to be a point right here. And we have points negative 3, 0, and 3, 0. So these are points right here. Okay, and remember, we do have an axis of symmetry going through the vertex. Well, we do want 5 points, so we're missing something. So we can use one more point and then reflect it. And I would say we should use maybe a smaller number, so we can use 1, negative 1, or a positive 1, doesn't really matter. So we can use 1 right here. So when x is equal to 1, so let's see what y is equal to. It's going to be 1 squared minus 9. I don't need that parenthesis there. Okay, so 1 squared minus 9, and that will produce 1 minus 9, or negative 8. So when we have 1, we have also negative 8 as the y-coordinate. And then we can reflect it. And now we have 5 points. You also could have used negative 2, by the way, and if you would have used negative 2, I'm pretty sure with negative 2, you will get negative 5 in both cases. So you also would have those other points. Right. So that's our graph. Okay, let's do one more example. So this one, we have y equals negative x squared plus 4x. So now notice there is no constant term, which once again means it can be used as 0. So therefore, our a is, now notice we have a negative there. So it's a is equal to negative 1, b is equal to positive 4, and c is equal to 0. Now our axis of symmetry is x equals negative b over 2a. So in this case, it's going to be negative 4 over 2 times negative 1. So it's negative 4 over negative 2, or 2. So axis of symmetry is x equals to positive 2. The vertex, we substitute our 2 for the axis. So negative of 2 squared plus 4 times 2. And then if you want, you can put plus 0 there, but you don't have to. And you calculate this whole thing, and you will end up with positive 4. So therefore, our vertex would be x equals 2, y equals 4. Now here, because our a is a negative number, we have negative 1, the graph will go downwards. It's going to be concave down. And since it's concave down, that vertex at the top now is going to be our maximum. Okay, y-intercept is done the same way. You substitute 0 for x to find your y. So we'll have negative of 0 squared plus 4 times 0. And in this case, everything will come out to be 0. So 0, 0 is your y-intercept. And to find the x-intercepts, we set the whole equation equal to 0. So we have negative x squared plus 4x equals 0. So now here, notice that we don't have a quadratic trinomial. We have a binomial, but it's not a difference of squares because we have a plus sign in the front. So here we can factor out the greatest common factor, which will happen to be negative x. So we'll factor negative x out, and remember we divide everything by negative x to see what's left. So negative x squared divided by negative x will become positive x, and then positive divided by negative will make it negative, and then x is cancelled, so we'll end up with x minus 4. And we still have a factored form, so this is still a product, so we set each factor equal to 0. So negative x equals 0, and x minus 4 equals 0. Negative x equals 0 means that x is still equal to 0. X minus 4 equals 0 means that x is equal to positive 4. So our x-intercepts are 0, 0, and 4, 0. Okay, so let's see what that produces. Our vertex is 2, 4. So 2 and 4. Then our y-intercept is 0, 0, which also happens to be the x-intercept. And then we also have the intercept of 4, 0. Remember, we have the axis of symmetry going through the vertex. So notice that we already have two symmetrical points. So we have the vertex, which is 2, 4, and we have two symmetrical points, which is 0, 0, and 4, 0. We still need one more point. Well, we'll pick the closest one to 2. So we'll pick the closest one to our vertex, which would be probably 1. So we can use 1 right here. And then when x equals to 1, we'll get y equals 1 squared, negative 1 squared. Write this. So negative of 1 squared plus 4 times 1. And that would be negative 1 plus 4, which is equal to 3. So when x is 1, y is 3. So 1 and 3. And then if we reflect it, we have this point, which means that when x is 3, y is also equal to 3. Okay, so we have those points and we have them on the graph, and then we draw the picture. Notice that the graph is going down. So as we said, it is concave down. Okay, so this is the lesson on how to solve quadratic equations by factoring. So hopefully everything is good and this is helpful. Have a good day, and math is awesome.